Hello, my name is Sally.
Hello, my name is Keela and we're here to talk to you about thermodynamics of gases, like those in our atmosphere. As we know, people have to abide by certain laws made from the government, like following the rules of the road, for example. Well, do gases have laws they have to follow too?
Gases occupy our atmosphere and make up the air we breathe. They are so small we can't even see them, but they still play a key role in our life. And they have to follow some laws too. One of those rules is called the ideal gas law. The ideal gas law shows the relationship between pressure, volume, and temperature of a gas. PV equals nRT. Let's review these terms before moving forward.
Volume is how much space a gas occupies. Gas always occupy the shape or size of the container that they're in, for example, like the air in this balloon. Temperature is a measure of how hot or cold something is, determined by how fast the molecules inside of the container are moving. And pressure is determined by how much energy the gas exerts on its container. In other words, how hard those molecules are hitting each other and the walls of the container that they are in. In the ideal gas law formula, R represents a constant and N represents the amount of gas that we have. For the ideal gas law states, as pressure increases, so should the temperature, and vice versa. For example, if we decrease the temperature on this balloon by pouring liquid nitrogen onto it, the volume must also decrease in order to make both sides of the equation equal to each other. So let's see. If we pour liquid nitrogen onto this balloon and decrease the pressure, or decrease the temperature, will we also decrease the pressure? As you see, when we pour liquid nitrogen onto the balloon and decrease the temperature, we also decrease the pressure and volume of the gas inside of the balloon. And now that I've picked it up, both the temperature and the pressure are now going to expand, and the balloon is going to go back to its original size. So, as you see, our balloon is now back to where it started. Looks like this balloon follows the PV equals nRT ideal gas law.
It is called the ideal gas law because it defines the behavior of most gases under most conditions. So let's see, is carbon dioxide an ideal gas? For those of you who don't know, carbon dioxide is a greenhouse gas. This molecule is composed of 1 carbon and 2 oxygen atoms. This canister is filled with CO2. Those molecules are packed in there, so the pressure is high. They're all bumping against each other and against the container. So the pressure inside this canister is much higher than the pressure of the air in this room. Okay. The gas is occupying the space of this canister. And notice one difference between this experiment and the previous balloon example is that this canister is not flexible. So let's think. If I open this valve and let some of the CO2 gas out, which variables in the ideal gas law will change? Pressure, volume, temperature? I'll give you a moment to think. Okay, let's test your hypothesis. First, we'll use this infrared thermometer to measure the temperature of the canister. Okay, it's reading about 23.9 degrees Celsius. That's about room temperature. Okay, now I'll open the valve. It feels really cold, and look, there's condensation forming on the canister. I can hardly touch it, it's so cold. Okay, let's measure the temperature too.
The temperature now reads about 7 degrees Celsius.
So when we open the valve, the CO2 left in order to balance out the pressure from the inside and the outside of the canister. That means the pressure has decreased from what it was before. And like we would predict from the ideal gas law, that causes the temperature to decrease also.
So, did carbon dioxide follow the rules? Yes, carbon dioxide is an ideal gas, and under most circumstances, a lot of other gases follow this law too. An important concept to remember from this is that pressure and temperature of gases share a linear relationship. As one decreases, so does the other. Since all the gases in our universe follow these laws, why do we choose to look at carbon dioxide? Well, we hear a lot about carbon dioxide these days and the role it plays in climate. As we continue to burn more and more fossil fuels, we end up adding more and more carbon dioxide into the atmosphere. CO2 is one of the top contributors to climate change because carbon dioxide acts as a greenhouse gas, trapping heat and warming our planet. So it's important that we as scientists study gases like CO2 so we can better understand our climate and continue to build a sustainable future.